Hello students! In our last video, we have studied SAS criteria of similar triangles. Now in this video, we are going to study about the ratios of similar triangles and the ratio of the corresponding sides. As we have studied that if two triangles are similar, then the ratio of their corresponding sides will also be same. Do you think is there any relationship between the ratios of the corresponding sides of similar triangles and the ratio of areas of these triangles? Yes, there is. The ratio of areas of similar triangle is proportional to the ratio of their square units of their corresponding sides. Now you know students that area is measured in square units. So you may expect that this ratio is the square of the ratio of their corresponding sides. This is indeed true, and we shall prove it in this video in the form of a theorem. So this theorem says the ratio of areas of two similar triangles is equal to the square of the ratio of their corresponding sides. So for this, let's make two triangles ABC and triangle PQR. This time it is already given to us that triangle ABC is similar to triangle PQR. Again, to prove this theorem, we'll have to do some construction. Students, can you recall how to draw altitude of a triangle? Yes, altitude of triangle means a perpendicular drawn from one of the vertices of triangle to its opposite side. So let's draw a line AD perpendicular to side BC in triangle ABC and PS perpendicular to QR in triangle PQR. To draw AD and PS, take compass and draw arcs on side BC and QR respectively. Observe that these arcs cuts both the sides in two distinct points. Now with the same radius, draw two other arcs putting compass at both these points of intersection one by one as shown. Mark the point where these arcs cut each other. Now join this point of intersection to the opposite vertex, and you can observe that the line joining these two points cuts the side BC and QR at points D and S respectively. Now the angle made here is 90 degrees, and thus both these lines AD and PS are our required altitude. So let us write down what we are given and what we have to prove. We are given that two triangles ABC and PQR are similar. We have to prove that ratio of area of triangle ABC and triangle PQR is equal to the square of the ratios of AB upon PQ, BC upon QR and AC upon PR. Now students, recall the conditions of similar triangles. It says that if two triangles are similar, then their corresponding angles will be equal and their corresponding sides will be proportional. Therefore, we can write AB upon PQ is equal to AC upon PR, which is equal to BC upon QR. And also, angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. Students, do you know the formula for finding the area of triangle? It is half into base into height. Now accordingly, we can say that area of triangle ABC is equal to half into BC, which is its base, and AD, that is altitude, gives us height, and area of triangle PQR as half into QR into PS. Now since we want to prove the ratios of these areas is equal to the ratios of the square of the sides, let us take the ratio of area of triangle ABC and triangle PQR. So we have area of triangle ABC upon area of triangle PQR equal to half into BC into AD upon half into QR into PS. So we can write this as area ABC upon area PQR is equal to BC upon QR multiplied by AD upon PS. This is our equation 1. Now we can see that in triangle ABD and PQS, angle D and angle S are 90. Why? Yes, they are perpendiculars, that is their altitude, and hence angles are 90. And we are already given that angle B is equal to angle Q since both these triangles are similar. Therefore, according to AA similarity criteria, both these triangles ABD and PQS are similar. And if these triangles ABD and PQS are similar, then the ratio of their corresponding sides will also be proportional. Therefore, AB upon PQ is equal to AD upon PS. If we replace them in our equation 1, we get area ABC upon area PQR equal to BC upon QR multiplied by AB upon PQ. Since we have already proved that triangle ABD is similar to triangle PQS, AB upon PQ is equal to AC upon PR, which is equal to BC upon QR. Therefore, we can replace AB upon PQ by BC upon QR in our equation 2. And so, equation will become area ABC upon area PQR is equal to BC upon QR multiplied by BC upon QR. Or we can say area ABC upon area PQR is equal to BC upon QR whole square. Now if AB upon PQ is equal to AC upon PR, which is equal to BC upon QR, then their squares will also be equal. That is, AB upon PQ whole square will be equal to AC upon PR whole square will be equal to BC upon QR whole square. So therefore, we can write area ABC upon area PQR will be equal to AB upon PQ whole square, which will be equal to BC upon QR whole square, which will be equal to AC upon PR whole square. Thus, we have proved that if two triangles are similar, then the ratio of areas of these two triangles is equal to the square of the ratios of their corresponding sides. Now students, in our next video, we will study another theorem related to triangles known as Pythagoras theorem.